Hello and welcome everyone to today's SANS webcast, Detection Engineering That Scales, Practical Strategies for Resilient, Maintainable Security Operations, sponsored by Splunk. I'm Abby Hansen from SANS, and today's featured speakers include Eric and Stamatis of SANS and Tim and Jordan of Splunk. If you have any questions during the webinar for our presenters, please enter them into the Q&A window at any time. And please note that this webcast is being recorded and a copy of the slides and recording will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Thanks a lot, Abby. Hey, everyone. So my name is Eric. I'm from SANS, and first of all, I'd like to thank you a lot for joining. It's always great to have such a nice audience to come and chat with us about interesting topics like detection engineering at scale. It was a nice intro, but we'll add a little bit of detail as well about who we are, what we do, and what we're here for today. The agenda for today is a pretty clear one. So no 20 different topics to address. It's pretty clear what we want to achieve. We want to first do a quick intro. Why could it be useful to, we might not know everything, but we do know a few things about detection engineering. So we'll talk a little bit about our background, who we are, what we do on a day-to-day basis. And then we'll run into actually the paper that we created. So we drafted a paper about detection engineering at scale, which we're very happy to share with the community. And we'll talk a little bit about what is in there, what are the conclusions, the things that we've seen, the things that we've learned. After which we'll have a look at a nice demonstration of Detection Studio by Splunk. So that's going to be a great fun, a nice combination of theoretical slides with, of course, the necessary practical details. Maybe a joke if I can fit one in there. I don't know just yet. And then, of course, the Q&A. So again, as Abby already mentioned, if you have any questions for us, do shout. We will take them. We'll probably take them at the end, though, to basically keep on going with our flow. So intros, I'll be brief. I already said it myself, but I'm Eric. I'm a senior instructor and author at SANS. I teach the 599 and 699 courses, which are basically the purple teaming courses. So one of the big things that we talk about is adversary emulation, how that typically works, how that can be useful as an input to detection engineering. So yeah, that's a little bit about me. So Tim, Jordan, Stamatis, feel free to go.
Awesome. Thank you, Eric. So hey, everyone, Tim Neri. I'm a director of product here at Splunk. Prior to that, I guess I started my career as a practitioner. So mostly on the offensive side, red teaming, pen testing, pivoted over to some of the defensive things, working on threat hunting. And ultimately, kind of my hidden superpower is I've been building products that customers like myself would want to use. So, finding gaps in the market, being able to fill those with product. Did a little startup thing that got acquired by Splunk. And now I'm here trying to solve detection engineering and threat detection at scale across Splunk ES and bringing Detection Studio to market. So nice to meet everyone. Jordan?
Yep. Thanks, Tim. Nice to meet you all. My name's Jordan. I started off as a SOC analyst. I became a detection engineer. I have been supporting, selling, and now building kind of very specifically for detection engineers over the past 6 years. So I'm a product manager specifically for Detection Studio here at Splunk. And I'm really excited to have this conversation. It's great to always talk more about detection engineering.
Hey, everyone. My name is Stamatis. I'm a threat detection engineer at Enviso. Before that, I was working for MSSPs, filling various roles from SOC engineer to SOC analyst. But for the last 5 or 6 years, I've been working for detection engineering, doing threat research and detection as code mainly. So yeah, it's good to be here.
So you have an interesting combination of someone who teaches and who says, this is how we should do things. You've got people who are actually trying to create solutions to the problems with Tim and Jordan. And then we've got the end user, Stamatis, who's trying to do detection engineering at scale. So I think that's going to be good fun. So overview of the paper. Maybe where are we coming from and where did this topic come from, if you will? Two sides of the coin. As we all know, the well, it's not a secret, security keeps on moving, right? The attack surface keeps on expanding. So things get always more and more interesting. How do we make sure that we have the right coverage when we're trying to have detection analytics in place in the variety of different platforms that we have, be that SIEMs, XDR, data lakes? How do we do that well? The good side, and so that's one side of the coin, is that I'm an optimist. I'm an eternal optimist, which means I always think we're always getting better and better. We see that security platforms increasingly ship with built-in detections, often mapped to things like MITRE ATT&CK, which makes it handy to, you start with something, right? There's something built in, you have a good view on coverage, so that gives you a solid basis. But of course, the attack surface continues to expand, so it's a bit of a cat and mouse game. You can't realistically expect vendors to just have built-in full-blown detection capabilities all done. So you will need that detection engineering capability in-house. You have a growing availability of community and online detection content. Things like Sigma, of course, come to mind. The idea is to have a sort of a portable way of exchanging detection analytics, and it's an amazing project. But of course, it's not just plug and play. You cannot just grab a Sigma rule, drop it in your environment. That doesn't really work at scale if you try to do that at large, if you will. And then, of course, the big one, the boogeyman, the one that's keeping us all awake. AI promises obviously accelerated analyst productivity or even engineering productivity, right? We can achieve more with AI. Well, probably we could and we can, but only when we get the basic right, when we have the plumbing in place. If you don't have proper detection engineering discipline, AI is a way to make us fail faster. I used to say that about automation. It's basically, if you don't have the basics right, it's going to speed up what you're doing. And if you're doing it a little incorrectly or bad, it's going to make you fail faster and probably also harder. So yes, it's a force multiplier, but we need to have the right basics in place. So detection engineering is very much a key, crucial capability for SOCs, for security operations centers to do well. And I didn't mention it in my introduction, but I'm also next to SANS. I also have to do something, right? Next to teaching. So what I do is I'm one of the founders of Enviso. So I run the managed security services business there. So the MDR practice falls under my scope. So I see firsthand what some of the problems are that we encounter. And what are some of the problems? I'll tell you. When we're talking to potential customers, prospects, or to existing customers, the conversations are often about what's your coverage? How many TTPs do you cover? What's your bingo mapping on MITRE ATT&CK, right? What do you color in? And I get it. I get the question, of course. But of course, MITRE ATT&CK is not a bingo card. It's also something I address at length in 599 and 699, so the SANS courses that I teach and author. MITRE ATT&CK is an amazing framework, obviously, and it's very helpful to see development priorities, but it's not a bingo card you can complete. So everyone's focused on this. How much coverage do you have? Can you build new detections? Can you add new rules? And more and more and more. We often have to, we've even had situations where they ask us, can you give us a list of all the detections that you have? So you don't see the detection analytics, the actual queries behind it, just the names of the detections mapped to MITRE ATT&CK. I guess it says something, but of course it doesn't say a lot. Because how qualitative are those detections? That's for one. But also, and that's really the key message of this slide, what is often underestimated is that it's not about developing new detections, or, well, that's part of it, but the bigger challenge is really how do you maintain it? It's a continuous process because detections require continuous tuning, maintenance to make sure that they remain relevant, but also operational, because this is a very fast-moving space, right? Things change, things adapt. So maintenance is truly the hidden cost. And it's already a bit of a sneak preview. One of the things that we feel is that this is where a lot of organizations struggle, and a lot of people, detection engineers, organizations are trying to build their own scaffolding to make it work, but it could be much better. The uncomfortable truth is that once you deploy detection, it starts decaying almost immediately. And a very practical example, if you've ever been in one of my talks or one of my courses, is I always love to use the very simple example of Mimikatz. Right? Mimikatz is, well, to be fair, I should update my example because Mimikatz, to be fair, if you see Mimikatz in 2026, you'll still see it, but it should be a bit of a, weird. Developing a detection for Mimikatz. Few things you could do. Very simplistically, one could look for, I'm going to look at process telemetry, look for a process name called mimikatz.exe. Is that bad? I don't know. It's arguably not extremely strong, but the chances of a false positive are quite low. Because if someone's running mimikatz.exe or any process called mimikatz.exe in your organization, you probably want to know about it. The problem, of course, is that it's very easy to evade. There's many variations of doing LSAS credential dumping without even using Mimikatz. So adversaries can very easily evolve the way they do things. So that's one of the reasons why you have decay in your detection rules the moment you deploy them, because the adversaries change around. There's variations of the TTP, but also on your side, the infrastructure changes. There could be new firewall rules put in place, new segmentation, and infrastructure change, which means that your log forwarding starts failing. Could even be a change in the log format, right? Maybe your parsers are no longer correctly parsing the incoming logs. So there's many different reasons why over time a detection rule will start decaying. And we try to visualize that here with a little graph, which shows you that there's always this uptick when someone does maintenance on the rule, when someone says, hey, let's fix this. But of course, that means that someone needs to think, that rule, what's the health of that detection rule? How strong is it? So metrics, it's something that we'll discuss in a bit, but it's very tricky to figure out where are we with this. So maintenance is very much a problem.
And I think to just kind of double click on that too, one of the things that you brought up again with Mimikatz is what we kind of like to refer to as the detection estate optimization problem. You know, if you went to, the Sigma community or you're looking through the Splunk rule set, there's probably going to be several detections for Mimikatz and credential dumping in general. Are you looking for, very specific kind of more signature-based detections? Are you looking for, behavioral patterns and looking for any process that touches LSAS in a specific way? And as we know, even with Mimikatz, there's different ways you can launch it. Like you mentioned, here's the binary and I can double click on it. But what if I'm using invoke Mimikatz, through PowerShell? Again, not that you're probably using PowerShell for that tradecraft anymore either, but there's lots of different ways and they all have different command line artifacts or different artifacts that they leave. And that also goes back to like, what data does a detection need to work? If I'm looking at, process access logs, but I only have process creation telemetry, I might not be able to use that detection. So that very basic process creation signature might be the best that I can do with the current, data that I have. So again, there's a lot of detection engineering work and discipline as we try and mature the tradecraft to making sure you have all that information, understand that. And I think that's kind of really key here with the maintenance problems too.
Yeah. Absolutely, it's a very good point, Tim, and it's something that I sometimes call it back on TTP coverage. It's typically not binary. It's not one or zero. It's like, but I cover, let's say again, Mimikatz credential dumping from LSAS. It's not one full coverage and zero no coverage. You're probably somewhere in between. But are you at 0.5, 0.1? That's where it gets very tricky, and it's a very interesting. It's fascinating, really, but that's a challenge that we face.
Yeah, I was just going to say the exact same thing. Like, it's a really hard problem to try and quantify when we think about coverage because, there could be 5 ways to detect Mimikatz using 5 different logs that all reflect the same activity. You can have Sysmon, you can have Windows built-in security event logs, you can have CrowdStrike, you can have any other EDR. If you have 3 out of 5 of those, is that covered, not covered? How much covered is it? It's really hard to say, but it's one of the challenges with using MITRE ATT&CK is like a strict scorecard or a bingo card. Yeah,
absolutely. And I think it results ultimately in this interesting catch-22, of course, for detection engineers, because the challenge for them is how do we keep on building detections or adding detections with an acceptable false positive true positive ratio, but at the same time, so you want to make it sufficiently specific so you don't have too many false positives. But at the same time, you want to have a relatively broad, let's call it a broad capability to catch TTP variations. And that means that it's an interesting ball game. So how do you do that well? And how do you, indeed, that state, how do you continue tracking it? But how well is your detection still working at the moment? So often that results in brittle detections. Maybe Stamatis, just throw out there to you. I think... Allow lists are probably the bane of your existence, right?
Exactly. So yeah, as a detection engineer, that's always the struggle you have, is how broad or how specific you make your query. And then the next thing that comes to mind is how much work do I need to put into the future to make this a good detection? And that usually translates to allow lists. So you kind of provision some allow lists that you know you might have to filter out on specific environments. And then, yeah, that's the big maintenance cost, I think.
Yeah, and obviously there's the feedback loop from the analysts, the people who are actually looking at the alerts when they trigger, where if you don't have, they don't necessarily have the right documentation to understand, okay, but what's the logic behind this rule, and how can we indeed, how do we build an allow list? Is that a feedback loop towards the detection engineering to say, hey, we need to tune this rule? So that's where things get quite interesting. So decay shows up obviously in an operational way, right? It's a subtle, never-ending story, but it starts showing up in analyst burnout. I don't think that's not a crazy statement. It's something that we see a lot. One interesting element, because you could say, Eric, don't worry, we have SOAR, we have automation, we have AI, don't worry, we don't have analyst burnout. One of the things we actually at one point encountered, and I found that fascinating, is that we actually deployed a detection rule which was creating a lot of volume in one of our customer environments, tons of alerts, but we didn't spot it because of the queues, because the automation was actually taking care of it. So it was just the automation playbooks we had were correctly enriching, contextualizing, and then making a determination, okay, false positive, get rid of it. But it's still not good to have the rule. And that was very interesting to say, well, you can have automation and maybe your analysts are not burning out, but you're still generating tons of noise, which you shouldn't do. So that's a very interesting, I was very surprised and happy with that as well. Look, nice, we're pretty resilient from an analyst or from a queue perspective. But that's interesting. Obviously delayed responses, missed incidents, if you have too much noise. A very interesting example of this as well is one of the things that I discussed it with our SOC manager recently, where we were having chats about should you tune certain rules, yes or no? Should you adapt certain things? And at one point, someone said, but Eric, you have to understand that, and it's very correct. He said, if an analyst has closed an alert that looks similar 10 times, right, the 11th time that he sees it, he no longer thinks. And he or she no longer thinks. And you can argue all of that about is that right or wrong? It's human nature. If you see the same thing going 15 times and 15 times you notice, okay, it's a false positive, then the 16th time it's also a false positive. So it's a very slippery slope to be mindful of. And that's really that reduced trust of analysts in potential detections, which is of course not something you would like. Obviously, when you're dealing with decay, it also means that you're taking away valuable time you could spend on covering new detection content that could be relevant for new threats that are popping up. So one of the key things here, I think, is the lack of metrics. Because I'll be honest as well, in our SOC, if I look at it, we manage quite a few different customers across different platforms. If I look at the metrics that we have, most of the metrics are very much focused on alerts. How quickly do we respond to alerts? How well do we deal with them? What's the false positive ratio, the true positive ratio? But you actually have metrics to have an understanding about the quality of your rules. And there's quite a few metrics that we'll discuss in the next slide where we give you some suggestions. But this is really a key topic. SIEM platforms typically don't come built in with nice metrics to describe how well the rules are functioning, how many times they, for example, triggered in the past. What are the data sources they use to trigger? So all of those things are typically a bit problematic, and it ends up with a lot of organizations and dedicated teams who are trying to build scaffolding to make that work. But there, I think we as an industry, as a community, we can do better. We can find solutions to make sure that detection engineers can focus on detection engineering, not on building additional tools and software to support their detection engineering activities. I think that's really one of the key things that we see here. So as we said, if you don't have the metrics, then tuning becomes reactive. Something breaks, so then you fix it. Again, alerts, fatigue. So you're in a reactive mode. You don't have predictive analytics, if you will, to figure out something's up, something is going to start going wrong. So it means that you're basically trying to catch up, which is never a good position to be in. So what could metrics look like? there's a few things, simple ones. And I think the simple ones we all see and we get true false positive ratios, right? How well is the rule behaving? Now, incident contribution, I think that's an interesting one. So to what extent do the detections that I have or the alerts I get from this rule, do they actually contribute to an actual incident being created? It's a very interesting thought, right? How valuable is it really? How often does this one contribute to a severe incident or a more serious incident that we need to deal with? What's the alert volume that it's generating? So how many alerts do we get from this rule? What's the average? Do we see that there's suddenly like an is the baseline off? Is it moving? Is it normally 200 alerts per week, but now it's 2,000? That's a problem. There's something going on. So patterns really in the alerting. What I also like, and that's one of the things that we started doing a bit more actively in our MSSP these days, is helping customers understand optimizing the log storage. Because there are, of course, cheaper log storage possibilities like data lakes typically, and then you've got more expensive log storage solutions. So the whole question in the game is always, do you ingest this, yes or no? And again, the industry is much more moving towards cheaper storage. So the issue is becoming a little less of a problem because you can store and potentially just review later reactively if you need to. But the key thing to understand is that if you're storing all of these logs in an expensive log format, are you actually using them? Do you have detection rules which are using the telemetry that you're ingesting? Because if 90% of the ingested telemetry contributes to 20% of the alerts, there's something off. It's not necessarily an alert problem or a detection engineering problem, but it helps to bring value to customers or to organizations to help them figure out where is really the blunt of this. Of course, health, are detections actually working? Operational cost, that's also a nice one. How good are your alerts actually for the analysts? If the alert triggers, can the analyst actually deal with it? Do they have the right information? Do they have the right context? Can they do something about that? Which is also sometimes an underestimated one. Much more on this. Again, the plan here is not to go through the entire paper. So I would highly recommend have a look at the paper because it includes quite a bit more detail on this, and it's a good read.
Yeah, I might add just like one piece of context around incident contribution and why that's so important to measure if you're not already measuring it. If you followed over the years the like IBM cost of a data breach report, you'll see that there's a section almost every year that describes what percentage of data breaches are actually identified by the security team and what percentage of data breaches are identified by the attackers themselves, like the attackers disclose it, and then what percentage are identified by a benign third party. And the good news is that the number of breaches that are identified by internal security teams seems to be going up every year. The bad news is that the most recent report says that it's something like around 50%. So what that means is that 50% of the data breaches, and that doesn't necessarily mean all incidents, but 50% of the data breaches are not being detected. And we also don't really know, what percent of incidents aren't being detected, right? Not every incident is a data breach. So that metric just goes to show that, like, again, detection engineering is still very important. There's a lot of room to grow, and we can't rely on attackers letting us know that they've breached us, and we can't rely on benign third parties letting us know, hey, you've been breached. So that incident contribution metric is really, really key for understanding the value that your program is delivering to the org.
Yeah, and I think kind of just to add at a higher level, like the reason we cling to simple metrics like number of detections deployed or MITRE attack coverage is because those are relatively easy to measure. And some of these are really hard things to measure and especially to do at scale. Part of the reason detection engineering has that maintenance burden, that debt, is because if you want to start measuring and tracking these on your own, that's going to take away from your day-to-day operations of creating and tuning detections and improving those. And really, we need more of these metrics to be built into tools and platforms, and being able to help take those kind of boring things away from a detection engineering persona and allow you to really focus on the bespoke things that matter most to your workflows. So again, I think that's kind of really what we're trying to start to build here at Detection Studio.
Yeah. Coming coming from the perspective of the detection engineer, one of the things I'm working on is actually trying to identify how many times I go and revisit a specific detection and how many times do I apply an allow list to that detection, so that I know over time how much time do I spend on that detection to maintain it. Because it's too much, it might point to something else, like I maybe need to deprecate the detection or revisit the detection logic because it's flawed in its nature. That's one thing. And the other thing is I'm trying to limit the time it takes me to identify why a detection is triggering so much. So most of the time that translates to, is there a pattern to the alerts? So is there a source IP specific that generates all this noise in the alert queue? And that's another piece of engineering and automation that I've seen a lot of people try to put in place to speed up their operations and the maintenance cost.
Yeah, thanks. And one of the, now we get to a very interesting piece for me, testing and validation, which is unfortunately a little bit immature. Oh, the stories I could tell about this. I've been doing quite a bit of work on purple teaming, TTP testing, automating that. I did a few RSA talks on this as well. Actually, the past 3 years, I've been doing a series at RSA called the Always On Purple Team, and how that would work with the idea of indeed actually continuously testing TTPs, doing that at scale. I will be honest, it is a very, very tricky problem because automating it, fine. You can rerun the same TTPs, but okay, there's a lot of scaffolding to put in place. I've been using the term scaffolding a lot, but I'm not an English native speaker, so once I stick to something, then I say it quite a few times. So just as a heads up. So I've been having a lot of fun with Caldera in the past couple of years, which I really have a hate-love relationship with. It's an amazing tool because honestly, it's free. Who am I to blame when something is free? But it's also sometimes a bit tricky to get right and to use at scale. But it's truly what you see is that there's a lot of ad hoc testing that happens manually. Things like Atomic Red Team come up. Those are all great initiatives and they work, but doing it well at scale becomes tricky. So how do you do that well? How do you track also did you get a detection, yes or no? We ended up often building entire automation playbooks in our SOAR platform to basically trigger the testing of a detection. And then also get the context from the SIEM, XDR, whatever source you would have, and then comparing it to make sure, that was a test I ran, so I have a proper detection, yes or no. And then, okay, you can kind of get it to work, but then you do think, it shouldn't be that hard. This should be something that we can standardize a bit better or find a better way around that to really get towards continuous validation and continuous testing. But I do think that there's a lot of attention going to this, and this is really a topic that we hear often.
Yeah, actually, if we can kind of go back to, again, testing, again, this is really a passionate project of mine. And, one of the scariest numbers for any SOC is the number 0. If I have, hundreds of detections and most of them have 0 hits, does that mean the threat isn't lurking in my network, or is that one of many silent failures? And, that's always a challenge. And if you're not doing enough testing and validation and quality assurance, and, as we look at detection engineering and detection as code, like we are literally copying what's worked in software engineering over to threat detection. And, quality assurance and testing is part of that process. So having more tools and built-in functions to automate and do those tests is going to be really important. And again, you also mentioned a lot of open source tools, and I just kind of want to give a plug for some of the ones that we have in our Splunk ecosystem. We've got Splunk Attack Range, which has been recently updated, that allows you to spin up a Splunk cluster in attacker and victim machines and, emulate, the specific adversary TTPs and things that you want to detect. That also really helps jumpstart the detection engineering because you have that smoking gun true positive log and, the telemetry that you need to write your detections for. That data can also be stored off and saved, again, for replaying, and we open source a lot of that too for attack data. So all of the detections we release, they have a corresponding event log that you can replay, and we have this script called Total Replay that allows you to, re-ingest that and test that. So lots of really cool open source stuff that we provide. And again, on the product side, Jordan and I are looking to bring more of those experiences into the Splunk too, to just make it easier and more accessible for everyone.
Beautiful. Yeah, that's always nice. It's amazing to get actual open source tools that we can use, that we can test, that we can play with. So I've actually played quite a bit with the Splunk attack range when we were doing some building of SANS labs. It's typically also something that we look at is how do we do this at scale. So it's indeed a pretty nice initiative. So thanks for that. Actionable alerts and context integration. So I think that's really we touched upon it lightly already, but what you do want to have in alerts is context, right? Context matters because again, one detection analytic can be highly effective in a given organization, but it can also be completely off in another organization. So context matters, and that context could be quite broad. It could be technical information about the system. Think process trees. So what are the processes running? What's the parent process? What's the child process? It can be vulnerabilities on a system. Maybe a certain detection is you might want to influence based on some context of the actual system that it's occurring on. But at the same time, as we all know, I think it's now almost, I'm almost beating a dead horse. No, not beating a dead horse, but I'm saying the same thing 2,000 times. But identity is the new perimeter. Everyone talks about it, right? It's no longer the endpoints. Now it's identity. Everyone's focusing on identity. But it is very true that most or a lot of attacks these days are identity centric. And of course, when you're trying to build identity-based rules or detections, then the users are tricky because users do unexpected things. They click around. A computer is relatively predictable. It's an asset. You have processes running on a computer, so you know what is the expected parent process of a child process typically. If you look at your core Windows process trees, you can kind of start creating a bit of a baseline of what it should normally look like. With the user, things get a bit hazier because, okay, but who is the user? What are they normally doing? So end user behavior analytics, what are they supposed to do? So that's really where things become interesting and where an additional challenge becomes getting the right context to be able to, one, influence the triggering of a detection, but also afterwards to allow the analyst to properly analyze. So once again, I think context is a big one, and having context in your ecosystem. Maybe one shout out to detection as code. And here specifically, I'm going to give a small shout out to Stamatis, who's joining us here very happily. But he's also been writing a pretty big series of blog posts about detection as code and detection engineering on how to do that. Is it a silver bullet? No, it's not. We already mentioned that we're trying to apply the same principles as we do in software engineering to detection engineering. And that makes a ton of sense, honestly, because it's very similar principles. But of course, doing that at scale, when you have a team of a few detection engineers, that becomes tricky. Just because a lot of we've talked about metrics, we've talked about context, we've talked about testing, we've talked about replay. A lot of that is going to require a whole bunch of tools to be put together. And before you know it, you might end up with a detection engineering practice, which has more software engineers than it actually has people who are doing threat hunting and detection engineering. And that's obviously something that we want to avoid. Don't know, Stamats, if you want to add a couple of thoughts here, feel free to shoot.
Detection as code is something I've worked a lot of the last couple of years. I did a lot of automation for our SOC and trying to deliver detections to customers and also make my life, my day-to-day life a lot easier by scaling with basically detection as code. So yeah, that's something we're gonna see about detection as code. It's not like you said, it's not like a silver bullet. It's not a solution that fits all organizations. But yeah, more on that as we go through the slides, I think, right?
Yeah, maybe Stamatis, just to illustrate a bit the topic here. How many iterations have we had of our, let's call it our pipeline that we're using to do this? I know we've worked on a variety of different technology projects, software projects that you've been mostly working on. I think some of it was self-developed. Then we had other pipelines. So it really shows the amount of time you've spent on that is massive, I guess.
Yeah, I spent a lot of time on it. We did use a legacy tool that didn't suit our needs, I think. And then we tried to move to a new technology. So that was one iteration of rewriting the whole stack. And then over that, we kind of went crazy with it and see what the limits of it could be and how much automation we can put into that to help us with our day-to-day.
So I guess here you can see a bit of a high-level workflow of typical detection as code. It's not rocket science, honestly. You would have a detection engineer, or of course, because we're 2026, you would have Cloud Code who writes a detection code or a detection query, which then gets pushed into a repository. Can be then the change in that repository triggers a pipeline or a CI/CD pipeline, so that you can actually review, validate the code. You can have it reviewed by peers, so you can have a peer review process. Just make sure, does that look okay? Does that make sense? You have an approval flow, and then of course it gets pushed into your platforms. Looks pretty straightforward. That's a very basic process that you could put in place. But where does it become tricky? As we mentioned, of course you can commit detections, you can run tests, you can build a whole bunch of testing on the schema, on the syntax validation, all of that. What becomes a bit trickier already is, can you actually test it against replay data? As we mentioned, there are some data sources, there's offline data sets that you could use. But there's also, of course, real-time emulation testing. But that's where you will typically have to start building, because it's not that straightforward to do. And then, of course, deploying the detection to platforms. There's tons of APIs that you can use. Platforms have that. That's also a relatively, honestly, out-of-the-box capability. So that's a good example of one of the things where testing the detection against replay data is, of course, a tricky one. Oof, this is a big one. Stamatis, you want to have a go at this one?
Yeah, something to add though on the previous slides, maybe on the testing part. Yeah, so the reason that you need to automate your testing is not because developing detection is hard. So you're gonna develop your detection, you're gonna do your test maybe on a test environment, and you're gonna check it once. But after that, when you modify your queries, you keep adding on entities to allow lists. And as time goes by, you need a way to retest that detection with your previous assumptions, let's say. So your data set that you previously had, and then maybe the new data that comes, and then adjust it for both of those data sets. So I think that's the most important part about testing and why that's necessary. But over to this slide. So what's my experience with TAG and whether I think it's useful or not? I think, yeah, absolutely, it's useful. I mean, this is coming from a perspective of MSSP. So for me to be able to handle all those different environments and be able to deliver rules and updates to different environments, basically, I would need a way to do that automatically, and this comes in the form of TAG. So there are benefits to that, but of course, like we said before, it's not a one-size-fits-all. It's not suitable for small organizations, I would say, or small teams. There is an engineering overhead that comes with developing pipelines, and there is some knowledge and upskilling that needs to be done. And the skill set that you need to develop detection as code pipelines is not something that you find every day on detection engineers. And it's not a skill set that should be required from detection engineers as well. So you want your detection engineers to focus on threat research, understanding the landscape, understanding detections, and not so much doing engineering work or spending their time troubleshooting pipelines and all this stuff. So yeah.
It makes a ton of sense. Oh, go ahead, Tim, sorry.
I was just going to say, I think the biggest thing is that detection as code is an accessibility problem, especially to smaller organizations. They don't always want to take on the burden of having to, manage, GitOps and DevOps pipelines. And, they want that maturity and that rigor of testing and quality assurance. Then they don't want to have to deal with all of the process. And I think that's really an area that we have to do better on the product side and all vendors, especially. And, if we went back a couple of slides, we don't have to, but just you look at that and it's a one-way process, how I'm going from Git all the way through the pipeline through to the platform. And again, that moves the source of truth outside of the product. And that makes even like very basic things, like if I wanted to go into the UI and just update a MITRE ATT&CK tag or something and have that syncing back to Git, the tools don't allow that today. So like there is an inherent cost to going full on detection as code that I think a lot of less mature teams realize. until they've, gone through and implemented that, and then they're kind of struggling and missing some of the basic creature comforts and things that you would like to have and be able to use the tool that you're paying a lot of money for and purchased. So.
Yeah, absolutely. Yeah, no, it's a very fair point, honestly. It's interesting, and yeah, it's I said I like how you said, Tim, that it's really it's an accessibility problem, right? For small organizations, it's a massive investment to even just start doing it. So it's honestly makes sense. And indeed, so as a practice, detection engineering has evolved. It has matured quite fast because it needs to. Because we need additional detection. We need, as we said, we need to build. We need to maintain our detections, right? We need to do that in a consistent and a structured way. We need to look at developing new detection rules. But so it has matured faster than the tools that support it. So what we think is that there's actually an opportunity, or let's call it an opportunity or a need. It depends a little bit on is the glass half full or half empty, right? But there's an opportunity to have typical log platforms, call it SIEMs, tools that you would typically use for your detections, where all the logs are collected, where you deploy your detection analytics. To go beyond purely an alert triggering system, if you will, but also include typical capabilities that you need to do detection engineering at scale. Think of native testing, right? Can we immediately test the rule? Can we make sure that it's done right without having to go through a number of pipelines which have been maintained by Jim, who no longer works with us, and so we keep on praying that it all still works, the testing pipeline that has been set up. But can we have that actually built into our platform that, as Tim said, we're paying good money for, so it would be an amazing feature to have. Can we get detailed metrics? We've talked a little bit more about there's much more beyond a true positive or a false positive ratio, simple MITRE ATT&CK coverage, but what's the health of our detection rules? How well do they work? How often do they trigger? What's the trend line, if you will? So getting much more of those metrics built into the platforms would be amazing. A tunable risk-based model, and we haven't really touched upon that here. We do that a bit more in the paper, but the risk-based models are typically the ones where sometimes detections can be a bit black box, meaning that it's a little bit what's inside, right? There's an alert which triggers, and of course, as detection engineers, the thing that you'd like to see is what's the actual query behind it. But there could be some machine learning going on. There could be certain risk scores which are taken into account that then trigger a detection. What we would also, of course, like is to be able to tune that. Can we adapt that? Can we fine tune that? That's an interesting one. And then, of course, for organizations who do really want to do detection as code, who want to build their own workflows, can we integrate it? Can we natively integrate into the platform in the tooling? So that's really a bit what we're looking at here, and where we think there's an opportunity to, again, and we've said it a few times now, but to make sure that the people who are doing detection engineering can focus on threat research, threat hunting, developing new detection analytics, brainstorming, finding new ones, testing them out and deploying them, not on maintaining the entire software stack that they need to be able to do this at scale.
Yeah, and on that, I think on the risk-based tuning, it's also about those low-fidelity detections that you always wonder whether to keep in the detection library or not. And you don't have a way to correlate or to define a model to correlate between those detections, those low-fidelity detections, because I think the trend now is moving towards treating detections as signals, treating alerts as signals. And so there is really not a good configuration. There's not good availability on configuring those models.
Yeah, and I think that kind of overlaps with one of the questions that was in chat is like, for my detection, should they be, more atomic, looking at one event log and triggering alerts? Should they be more correlation or anomaly based? And, what about risk-based alerting, And I think, again, really, it's going to depend on what threat and TTP you're tracking. If it's really high confidence and you can, just fire off an alert, absolutely do that. But a lot of the best rules are, again, because attackers like to live in the gray area and live in the noise, and blend in, are going to be more of those risk-based alerts that are going to look for specific patterns and look at the breadcrumbs or signals. And when you can have an engine that's powerful enough to do the correlation and find and surface those, that's really, again, where the tools have the most benefit, and especially when you're able to correlate across multiple log sources, not just looking at endpoint data, but marrying that with network telemetry and identity and email and DNS and all of those sort of things.
Righty. Now we get to the fun part. I hope we've made the necessary sacrifices. We have a small demonstration of Detection Studio, which I'll happily hand over to the experts at hand, Tim and Jordan. So if you want to steal my screen share, feel free to do so.
Yeah, let's do that.
I'm seeing a couple of questions in the meantime in the Q&A, so there's a couple coming in. If you have any additional ones, keep them coming. We'll have some time after this to address them, so don't be shy.
All right, screen sharing good?
Yes, I think.
Okay, cool.
I still see mine, I think, but maybe it's just me. Do you still see the slides?
You'll need to click on each. You can see at the very top of your Zoom screen, you can click on Jordan Camber's screen or Eric Van Boegnout's.
I hadn't stopped. That's why I stopped now. So.
Okay, cool. Well, I know that we don't have too much time, so I'm going to do kind of like an abbreviated version of this because I want to make sure we leave time for Q&A. But at a very high level, in a nutshell, what I'm showing you now is Detection Studio. Basically, it's a set of features inside of Splunk Enterprise Security that are designed specifically for detection engineers and detection engineering. There are kind of two primary use cases that we have for now. The first one is helping users improve their detection coverage from a MITRE attack perspective very quickly and very strategically. And then the second use case is to help users maintain all of their detections after they've deployed them by helping them essentially in both cases solve for some of these, as you've seen, like measurability and metrics problems, right? So the kind of like core underlying issue that we address and that I'm going to explore with you kind of very briefly is like, what does a good detection look like? And how do you define that in a way that makes sense for most users? And how do you measure that in a way that's repeatable and scalable and effectively like more scientific, right? So what Detection Studio does is we look at a couple of things. Number one, we look at all the out-of-the-box detections that we're providing you that you haven't necessarily enabled yet. And we give those detections what we call a priority score. You can think of it maybe like a recommendation score, right? And this priority score basically tells you, hey, this is a really good detection. You should probably deploy this one first because it has the highest priority score. And then what we also do is we use the same metrics, which I'll dive into in a second. We use those same metrics to describe the health of the detections that you already have deployed so that we can give you good visibility into which detections you're using that maybe might have some quality issues. And so I'm going to explain a little bit more about how that works by comparing two of these detections. We're going to look at one of these detections, which is highly recommended. It's a good detection. And then we're also going to look at one of these detections, which is very low health. In other words, it's probably not a great detection. You probably need to take a look at it and tune it. So how this works at a very high level is that we essentially have broken things down into like 4 what we call KPIs. And these KPIs are measured, they're calculated, they're all scores. And these 4 scores, they kind of bubble up into a single score, which is either priority or health. And each score is meant to represent a different bucket of questions or things that you want to know as it relates to understanding what a good detection looks like. So the first one is compatibility. And really what compatibility reflects is, do you actually have the data coming into your environment to use a given detection? So if we look at this detection, we can get a little preview. You can see that it uses, in this case, inside of Splunk, it uses an endpoint data model and the process data set. So we actually extract those requirements out. We check to see whether or not you have those data models and data sets and whether or not they're populated. And if you do, then you get a check mark on all these and it passes, right? So you can compare that with a detection which is low health. And in this case, this detection uses the endpoint data model, but it uses a data set which is registry. And in this case, for this detection, it looks like in this environment, there's nothing in the registry data set. So we have the data models installed, right? But there's no actual data for this detection to trigger on, and it's enabled, it's implemented. So even though this detection is enabled, it's never going to fire. And if it never fires, then that means that detection is probably unhealthy. So this is one of the factors that we use. We also look at what we call confidence. So confidence is really just a measurement of like how much expected alert volume can we estimate. And so we do that by like running the search and seeing what comes back and then trying to normalize this and then give it a score based on a threshold that you can configure. And so in this case, we can see that the confidence is like 70, which is like relatively high. It's not super high. And then roughly there's like six results per day, which again, it maybe is a lot, maybe is not too much, depends on really your standards in your environment, which is why this is customizable. But if we go and we look at a detection which is low health, you can see that the confidence in this case is 0 because we get something like 19 results every day. And so based on where you set that threshold, right, that's how that confidence score gets calculated. And then we also have performance, right? So you probably want to know for a given detection that you write, like how long does it take for that detection to search? Like what's the compute load? So we also measure that in a couple of ways. We look at how quickly it scans events. We look at how long it takes to scan a certain time period of events, and we give each of those things scores. And you can see in this case, it takes a really long time for this detection to run, but a really good detection will run a lot faster, right? It'll scan an hour's worth of data in 8 seconds, or it'll scan 12,000 events per second of like wall clock runtime. And then the last thing that we look at for prioritization is impact, which this comes back to MITRE ATT&CK. And we've talked about how that is kind of like a tricky problem to solve. But essentially what we do is, because in the platform, we have this MITRE ATT&CK matrix, it's very kind of attack navigator style where you can see what you have deployed and what's available for each technique and each sub-technique. Because we have that measured, we can also look at what the detections that you're not using, what they cover. And then we can also contrast that with how covered those things already are. So essentially the situation that we're trying to avoid is, you've got a detection, you're not using it, it's for a technique, but that technique is already relatively well covered. You've got like 20 detections deployed for it, right? So that's not really a high impact detection. It's not something that's going to move your overall coverage meaningfully. And so what impact does is it calculates how much additional coverage it's going to provide you based off of what you actually have enabled and deployed in your system. So this one's a high impact. You can see it covers a lot of different sub-techniques, and many of these sub-techniques have relatively low coverage. And then this is an example of a detection that has a lower impact because it covers one sub-technique. The coverage is pretty low, and so it gets like a lower impact score. So there's a lot more to this. There are like different ways to slice and dice this data. You can sort and filter on a lot of columns to solve a lot of other like interesting use cases and questions that we have, like, what would provide me the most coverage, but I don't actually have the data for it. And that might tell you what data you need to collect. I do want to make sure that we leave some time though for Q&A. So I might stop there and pause there and I guess hand things back over.
Thanks, Jordan. If I may, one quick question, as I was very looking at it very interestingly, and maybe this is a naive question, so you have to tell me, the measuring the true positive versus false positive ratio, how do you capture that analyst feedback? Is it built into the platform, or how does that work? Maybe it's not even only analyst feedback. I'm just openly wondering.
It's a good question. So like strictly speaking, what you just saw doesn't actually incorporate any analyst feedback, right? Like true positive, false positive. However, there's a plan to incorporate this. And the good news is that within the Splunk ecosystem, provided that you use the case management system that's built in, we actually have the information and the data available. So we can see what we call it a disposition code. We can see what the disposition codes are. We can map those to some more generic categories like true positive, false positive, benign. And then we can also bring those metrics back into this interface and make them part of the calculation.
Oh, nice. Yeah, I must say it looks very, it's impressive. It's, if Stamatis, if only we had this in our, we need to have a chat afterwards.
Yeah.
No, thanks a lot for the demo. It's always nice to see things in practice and to see a potential way of dealing with some of the challenges that we just discussed. I'll just bring up the slides just for a quick second again. There we go. So we actually had a fallback if the demigods would not like us, and it's actually an image, but this was much more fun, right? So I'm just going to skip through that image and bring it to Q&A. Actually, of course we have the key takeaways. We'll finish with those, and then we'll actually touch upon the Q&A. So I think no surprise here. A quick recap in the last 5 minutes of our webcast. It's really a life cycle discipline, not a rule writing task, right? That's detection engineering. It's a continuous process where you need tools that support such a continuous process. It's not a one-off, and it's really it's not something you can just get over with and done. You have engineering fundamentals. There's testing, there's versioning, performance telemetry, so understanding how well the rules work, making sure that you can deploy, you can roll back. Those are all things that, again, as we discussed at length, quite often additional tools are built, small scripts, which then, as I already mentioned, Jim might build them, but then Jim leaves your organization in 2 months. Those things are tricky to deal with. Detection as code is absolutely a very strong basis, and it's a very good principle to use and apply. But of course, if you don't have platform support to support detection as code, then the complexity really becomes the problem of detection engineers, which then results again in them not being able to spend sufficient time on actually developing or maintaining the content. So we really believe that the next platform evolution is really supporting these primitives, supporting what we need to be able to detection engineering at scale, replayable testing, observability, health metrics, tunable correlations, being able to roll back rules. So really maintaining, supporting detection engineering in its entire life cycle, not just in the let's deploy it and we're done with it. So that's really a bit the vision that we see and the point that we're trying to make. I'm not sure, Stamatis, Jordan, Tim, if you have anything to add on these conclusions before we go into the Q&A.
I think you summed it up pretty nicely.
No, I just want to say this has been a great partnership. Enjoyed working on the paper with you. I definitely encourage all the attendees to take a look. And, thank you all for watching the webinar. But yeah, let's get to some Q&A.
Yep. We have a few already answered questions as well. So I'm just going to repeat them just so that everyone knows the question, because I think it's only visible to us. There was one question about how do you see SOCs generating alerts based on single event alert signals instead of SOCs generating alerts or investigations based on multiple weak signals, low fidelity alerts, basically the one-on-one, one alert becoming one, or one signal becoming one alert. So Stamatis had a small answer to that, but indeed, what we see more and more is that one-on-one relationship is not necessarily there anymore, because what you often see in bigger intrusions or in typically important incidents, if you will, is that there's multiple low fidelity signals which are present, but there's not one big. There's not a one-on-one alert that is critical, let's say. The tricky part there becomes indeed, how do you tune that model? When does it work? How does it do that? How does it stitch together those low fidelity alerts to become an actual, let's call it how do 5 low fidelity or 5 low severity alerts or signals become one critical issue when it's required and not when it is not? So that's an interesting topic. So yeah, that's I think indeed the future is honestly, if we can do it well, it makes sense to be able to put those 5 low fidelity in one big one. But of course, we need to be mindful of false positive, because otherwise we end up in the same situation with it becoming tricky. There's a very practical question. Does the latest release of Attack Range allow for on-prem deployments or only cloud-based? I think, Tim, you responded to that, but it's cloud only, but there's multi-cloud support. There's a ton of new features also in the latest version 5, so definitely have a look at it. So will it be available for all enterprise search customers? If so, what version? I think Tim responded it's 8.4. Then we have some more questions. Will this sliding be made available? Yes, absolutely. Metrics for detection page. This is an interesting one. How healthy or not is detection? Are there entities available so you can quickly observe the possible root cause of issues for the specific detection? So I think the question here is, what entities would you look at to observe or to find the root cause of potential detection issues? Right, I think that's a bit the question here. The answer, if I may, I think it it will depend, right? Because it depends on what is wrong with the health. I think what Jordan showed, I liked a lot in the demo was if you can see, for example, but it's using certain fields or certain data that we actually don't have. So this alert will never trigger. Then it becomes very visible where is the potential issue or the potential problem. But I think it depends a little bit what is the health issue that we're looking at here.
Yeah, and I think just to kind of double click on that, the different KPIs are measuring different things. So like compatibility is measuring, do I have the data for this detection to work? So if you have a data health issue, your compatibility score is going to be low, and then we know we need to go take a look, and we can probably try to start diagnosing what those look like. Is it, did the schema change or the underlying data structure, or is there a missing field, or is there, some other part of my data pipeline? Same thing with like confidence. Like if a detection is starting to go noisy, then we'll be able to say, hey, here's some examples of false positives and take you to a tuning workflow or use an agentic tuning method to, help automate that. So, as we start, you can't improve what you can't measure. And as we start to measure, there will be additional workflows that we'll have to make a lot of those, again, tasks a lot easier.
All right. We have 1 more minute. So I'm trying to, there's a few more questions. Measuring false positives and their associated causes mainstream. So measuring false negatives and taking actions to reduce their frequency, blending offset data with the blue one in one pure purple dream. I think the whole point of false negatives, that will require testing. Well, and not testing with, does it require the type of testing where we emulate TTPs and then we figure out, do they actually trigger when we expect them to? I think that's the answer to that. So if we want to look for false negatives, that's what we need to look for. Do they actually trigger when we expect, when the TTP activity happens? Complexity there, of course, becomes what level of complexity of TTP are you going to emulate? How are you going to do that? Do you make it harder or easier? I do think we're at time, so I'm always a little cautious. We have a few more questions here. What I would say is our contact details are on the slides. So just drop us a note, hit us up on X or on LinkedIn. There's a few more questions, but we always need to be mindful of time and not overrun our slot. So we'll be happy to follow up with you. And thanks a lot for joining, and do have a look at the material. Also, thanks to everyone who's worked with us on this. Tim, Jordan, thanks a lot. Stamatis, thanks to you too.